So, hello and welcome to today's lesson. So, today's lesson is going to focus on the Lambuth Formula, and we are going to consider when we have a piecewise function. Okay, so I'm Boydo Kanrindo, a third year student of Mathematics KNUSD. Please don't forget to like the video and please subscribe to our YouTube channel. Thank you. So, in one of our previous videos, we talked about this same concept, but we used a different approach. So after reading more, I realized that there is a more appropriate approach that we can use in tackling questions of this nature. So today I'm going to introduce you to that concept. Okay. So we are going to use that to solve this particular problem here. So we are supposed to solve using the D'Alembert formula this particular wave equation with initial conditions. So this here is our wave equation, and this here is our initial velocity, and this here is our initial displacement. So you can see that we have something on similar here, and that is our initial displacement is in a piecewise function. So that's the type of problem we want to tackle in this video. So whenever we have a piecewise function, what we do is that we use the Heaviside function on the piecewise function. Okay, so we introduce the Heaviside function. So let's quickly revise something small in the Heaviside function, which will help us to be able to write this in that form. So we are to write this piecewise function as a Heaviside function. Okay, so this is a piecewise function. So in writing it as a Heaviside function, what we do is that it is going to be whatever we have here. So 0 times h of t minus whatever we have here, then minus h of t minus whatever we have here, 1. That's what we have this here. Then plus t minus 1 times h of t minus 1, then minus h of t minus 2 because of this, then plus t plus 1, then h of t minus 2 because what we have here. So this here is the Heaviside for this particular piecewise function. So whenever you have a piecewise function, this is what we do before we start solving. Okay, so in a question we had this piecewise function, so we have to write the Heaviside function for it. So that means it's going to be 2x times h of x minus 0, then minus h of x minus half, then plus 2 times 1 minus x, then h of x minus half, then minus h of x minus 1. So this here is a Heaviside function for our piecewise function, and this was what was given to us in the question. So that means since you're able to reduce our piecewise function into this form, then the rest becomes so simple to follow. So we quote out the Lambuth formula, which is given by what we can see here. Alright. So you should note that with this particular thing we can expand it, and this will give us 1 over 2 pi of x plus ct, then plus 1 over 2 pi of x minus ct. I hope you know that. Right, so the wave equation given to us in this question was of this form, and comparing that to the general form of the wave equation, we can see that our c squared is equal to 1, meaning our c is 1. So when we put c equals 1 into the D'Alembert formula here, then it's going to reduce to what we can see here. So u of x2 equals 1 over 2 phi of x plus t, then plus phi of x minus t, then plus 1 over 2 the integral of real of s ds from s minus t to s plus t, right? So now this here stands for the function here stands for the function for our initial displacement, and the real of s here stands for initial velocity. So from the question Mm, our initial velocity was x, and the whole of this was our initial displacement, which we've written a Heaviside function for it, and this is the Heaviside function. So that means that when you make the substitution, the part where we have s plus t, wherever you find x here, you put s plus t there. The place where you have s minus t, wherever you find x here in this particular thing, you put s minus t there, right? So making substitution is going to give us what we have here. So you can see we have 1 over 2 times s plus t. Instead of x, we do it s plus t. Then we have this here, that here. So wherever we find s, we put s plus t there, right? So we're going to have this lengthy thing here. Then plus, so now we are coming to put s minus t. So plus 1 over 2, then 2 times s minus t, then h of x minus t minus. So this also takes the x minus t. Then we have something lengthy, as we can see here, right? So then we have plus 1 over 2, then the integral of s ds from s minus t to s plus t. So solving this integration here, we are going to have 1 over 2 times, when we integrate x, we get s squared over 2. The limit of integration is from s minus t to s plus t. And when we put in the limits of integration, we are going to get s plus t squared minus s minus t all squared all over 4. So expanding this here gives us this, and this also gives us this. So when you try to simplify the numerator, we have this here all over 4. And with this, at least s squared will cancel this cancels this. So we get 4xt, that's what we can find here, then all over 4, which gives us xt. So that means that now the sorry, the final solution is going to be this huge thing here, plenty thing here. So we have our u of x to be equal to 1 over 2 times whatever we have here. I hope you can see that. Then plus 1 over 2 times whatever we have here. So that was from the Heaviside function, making a replacement. Then plus st. Okay. So thank you very much. Don't forget to like the video, subscribe, and share it to your friends. Thank you.